We're graphing complex numbers. So here I have a complex number, and the first thing to notice is that the computer's going to always refer to, well, we actually always refer to complex numbers as z, so that we can distinguish between the fact that when we have an x equals, we're often talking about the x-axis or a real variable, or y equals, we're talking about the y-axis or a real variable. And when we're talking about z, we know that it's complex. So 3 plus 4i, how did I get it? Well, it's right here. If you notice, we went over 3 and up 4, and that's because this is on the complex plane. This is the real axis, and this is the imaginary axis. So you always need to know, do you have the real plane with the xy axis, or do you have the complex plane where this is the real axis and this is the imaginary axis? So let's look at z2 here, negative 2 plus 6i. Well, what did I do? It's right here. I came to the left 2 and up 6. Now, GeoGebra doesn't like when you put text boxes in and then go back to complex numbers, so we're going to open another window. Here we see we've got 5 minus 2i. All right, so what did we do? We came over 5 and down 2. We'll do one more. Negative 3 minus 6i. That's over here. What did we do? We came to the left 3 and down 6. So that's how you graph complex numbers. Now, what about the absolute value? So if we look, absolute value of a number means its distance from 0. So that's why 9 and negative 9 have the same absolute value, because they're both 9 units away from 0. So the absolute value of 9 and negative 9 are both 9. Well, the same is true for complex numbers. When we talk about the absolute value of z1, we're talking about its distance from 0. Well, what is its distance from 0? Well, it's the shortest distance. So from here to 0, it's the hypotenuse of this triangle. Similarly, for z2, what's its distance from 0? It's from z2 to 0. It's the hypotenuse of this triangle. So what is the absolute value of negative 2 plus 6i? Well, I just need to use the Pythagorean theorem. So the length of this side, which is 2 squared plus 6 squared, equals k squared. So the absolute value of negative 2 plus 6i is the square root of negative 2 squared plus 6 squared. And if we come over here, we can do the little math for us. So if I do the absolute value of negative 2 plus 6i, it's 6.32. Okay, and that makes sense. It's the square root of 40. So we know it should be between 6 and 7, so we believe that number. All right, similarly over here, whoops, let's get rid of that, sorry. Over here, the absolute value of 3 plus 4i, well, 3 squared plus 4 squared is j squared, so the absolute value of 3 plus 4i, the square root of 3 squared plus 4 squared, and that's going to be equal to 5. And again, GeoGebra stops working with complex numbers after you type in text boxes, but if we type that in over here, absolute value 3 plus 4i, it returns 5. So let's look at z2 here, negative 3 minus 6i. So, well, what did we do? This is going to be the test of whether GeoGebra is going to work for us to do this. So segment, what did I do? I came left 3, and then I came down 6. So we're looking at the hypotenuse here. Okay? So it should be the square root of 3 squared, or negative 3 squared, plus negative 6 squared. So that's going to be the square root of, what's that going to be, 45. So let's see what it does for us if it works. Negative 3 minus 6i, and it returns for us 6.71. I feel pretty good about that because, again, 36 plus 9 is 45. We should be getting a number, no, the square root of between 6 and 7, which we did. Okay, and lastly, for z1 here, 5 minus 2i. And remember that it's a squared always plus b squared. So this right here, this is going to be 5 squared plus negative 2 squared, or 25 plus 4. Okay, so we're going over 5. So that's my a. A squared is 25 plus b squared is 4 equals c squared. So k squared is 29, so k should be the square root of 29. We should get some number between 5 and 6. So absolute value of 5 minus 2i, what does it give us? 5.39. So that's how you graph complex numbers, and that's how you get the absolute value of complex numbers.